All right, I think we're going to try to get going here. So my name is Chris Andrews. I am the 3D product manager for Esri, and with me is Sean Morris. He is a product engineer, not a solution engineer, on the scene layers team. And we have, is there anybody here who was in a talk with a similar name yesterday as part of the partner conference? No, other than Sean and me. That's good. I am, one, I'm sorry. All right, well, what you're going to get is you're going to get a lot of the similar content condensed down a bit, and then Sean is going to take some time and do some demos for you folks. I'm going to do my best to recast the content so that you can understand how it's useful to you as a developer. And just so you know, my background was, I was a programmer since I was like 11. And then when I got into college, I think I've taken one programming class ever, but I ended up teaching myself GIS, building a GIS of my own for my master's work. And then, this was a long time ago. And then when I got out of school, I realized that GIS and programming were two very marketable skills back in the 90s. And so I actually had a long career as a developer, and mostly in enterprise integration around GIS, before becoming a product manager at Autodesk for about 7 years, and then briefly at IBM, and now I've been at Esri for 3 years. I've been in 3D for pretty much since I got to Autodesk, but GIS for about 20 years. All right. So I will show some roadmap information in here. That roadmap information shouldn't be tweeted or talked about too much outside here. If you want to, you can survey us and tell us how good we did. So has anybody attended this presentation last year? No, other than Sean and me. Good. How about, are you guys already using 3D in your development efforts? How many are using 3D? Okay, so few, all right. And all right, how about, are you guys hearing about BIM, building information modeling? So definitely, okay, some. And then what domains are you guys in? Defense and intelligence, okay, utilities, all right. Public safety, big one, all right, cool. We're getting lots of 3D demands in those areas. Other stuff, lots of good stuff. All right, so what's happened in the last couple of years is that there have been massive amounts of new data types and methods of collection that essentially have brought us to a point where a few years ago we would not have thought we could be. So many of these data types are 3D, 4D, they can be used to extract 3D information. And what's happened is that this data availability is driving the demand for new experiences around GIS and mapping. One of the reasons that I talk about 3D and not 4D or 5D or 7D or other things that people say I should talk about, ND, is because 3D is it's a common buzzword that relates to a visual experience that everybody experiences every day. And 3D also, in the minds of many consumer types, is associated with many of the other things that we're being asked for in modern interactive applications, like immersiveness, consumer level usability, making things visually compelling. Jack is now talking about making maps beautiful. I won't joke with you. One of the things that I walk around Redlands and I am shocked at how many ugly maps Esri developers and product engineers and others have hanging on their walls. And I'm really glad to hear Jack now talking about the need for maps to be tell stories, be compelling, and be beautiful. Because 3D for years has been about making compelling stories that make sense to people, but also that often need to be attractive enough to make sense. So it's good. All right. 3D has its own intrinsic value that's different from 2D. I might have never said the first one up here a few years ago, but people kind of joked about it. The 3D could possibly be a more accurate representation of the real world than 2D. Well, actually now if you look at all the LiDAR scanning that's going on, scan to BIM, interior, all kinds of interior, drone data capture, all kinds of crazy stuff that's going on now. Photogrammetric mesh extraction. You now actually are at the point where you can achieve a more realistic version of the real world in a digital environment with 3D than you can with 2D. 3D is also helpful for visualizing stuff that either you just can't get to, like underground stuff, or stuff that doesn't exist yet. It's very useful for communicating with non-technical stakeholders. I've been in meetings, community meetings, where you show them an ortho photo and they have no idea where their house is, but you put them on the road and they know exactly where their house would be if it's not where they, in perspective, if they're not standing in front of their house. And then 3D is very useful for analyzing behavior and aesthetics. I mean, what does brick look like in a 2D map? What does a door swing really look like in a 2D map? So, okay, the team that I work with is basically trying to build out 3D capability throughout ArcGIS. And I jokingly said to Jack after the plenary on Sunday that if I had been playing the Autodesk and 3D drinking game, I would have been under the table by the end of the session. So 3D is really already everywhere throughout ArcGIS, and we're starting to see it pretty much everywhere throughout our users. Our more innovative users are basically telling us that a modern GIS is 3D, and they expect that all of their future GIS work to have some 3D component, or to start in 3D and use 2D where necessary. My team, in order to make decisions about what we do, we're focused on driving 3D adoption throughout ArcGIS. We're focused on expanding the capabilities of GIS through 3D technologies. We are also focused on delivering better experiences, right? Just because it's new and complicated doesn't mean it has to be hard. And then we're also interested in growing Esri's impact in new and expanding markets. So you'll find that my time, for example, is about 50% on the BIM market these days. So it's not even what you would consider a traditional GIS market. GIS these days is 3D. So my job is focused on 3D across ArcGIS. And we are trying to build out 3D to be very consistent with what you think of as classic 2D web GIS. So it's services-based. We will be delivering new clients and experiences. We already have delivered some new clients and experiences. We're focused on workflow modernization around the use of GIS data. And then we also do things from kind of a story-driven development paradigm. For developers, there are tons of opportunities for working with 3D at this point. For the very first time as the 3D PM at Esri, I have a mobile app that's 3D on my Android phone. And it only took 3.5 years of me being here to get there, which is kind of sucky if you're the 3D PM, right? But that mobile app is now out on GitHub as a free sample for anybody who wants to play with it. And then I believe we have an iOS sample out there too. Later this year, we should start to have our first production app, but there are lots and lots of other app opportunities, for example, for developers around 3D. So mobile, embeddable workflows, I fully expect us to be starting to play in wearables. Content creation, we have new standards that I'll talk about in a sec, and we have quite a few developer partners that are now starting to create data in these standards. And then you can do a lot of the classic enterprise integration and workflow customization things in 3D GIS that has been done in 2D for years. When we're talking about 3D, there are some concepts that are useful to understand. A web scene is like a web map, is a kind of virtual collection or container for layers and other information about a 3D map in this case. So slides, the time of day maybe, the order of the layers in the TOC, grouping of layers, all that kind of stuff happens in a web scene for 3D. Then in 2018, we want to be able to build out and deliver what some people might think of as like the Google Globe, transportable globe deployment pattern. So the idea that you can take a couple terabytes of 3D mapping information and 2D mapping information and put it on a hardened laptop in the field, or maybe it's less than a couple terabytes, but you can deploy it on a mobile device like my phone. That should be coming in mid-2018 to start, and then we'll be building that out from there. And Web scenes and mobile scene packages, a key component of them are these scene layers. And scene layers are large caches, potentially large caches of arbitrarily large and heterogeneous GIS information that's typically 3D. Like 3D buildings, we're looking at how we can move BIM data into 3D, into scene layers. 3D points, point clouds, Sean will show you a lot of this stuff in a little bit. And then we have lots of plans for where to go in the future with scene layers. But so you'll hear, like I hardly ever open a 2D map online. I think it's maybe, no joke, less than 20 times in the last year. But I'll open hundreds of web scenes up and online. And those web scenes often have scene layers, and they have other layer types too. I3S, this scene layer specification that we released back in 2015, is now an OGC community standard. This has been hugely helpful for us in Europe and in some US government conversations. So you actually have the GIS 3D standard for that is in OGC right now for large cached GIS data. It's an Esri submitted standard. There are a couple of others that are competing, but none of them have made it through the standards process yet. So this has been a pretty huge thing for Esri. We don't care if other people want to create the data or even consume it. You can even build an entirely non-Esri stack around that data standard. And that's perfectly fine with us because you know what? Anything that is too standard would be consumable or deployable by an Esri client or server environment. So it's been a really great thing for us. Oops. Okay, so I'm not going to spend much time on the product stuff. You guys know we have ArcGIS Pro, and we have City Engine. Pro is in my old Autodesk lingo, I'd call it the digital content creation tool for 2D and 3D GIS. So it's the professional tool for GIS authors and content creators and data curators. City Engine has been repointed toward being an advanced authoring tool for urban planning, and it's going to go a lot deeper there. Pro has an extensive API for .NET, and then also Python. As you guys know, you can run it headless. You can actually run it headless to like cook 3D content if you want. And then City Engine also has a Python API and I think a CA API as well. So all of Esri's tools are built with APIs, and you guys probably already know this better than me. We have apps. I'll simply say that this is the year where we should start to see some actual mobile apps come out, because that's what I think of when I think of apps. But in the Esri lingo, everything is sometimes an app. Earth is something that I worked on pretty heavily for a couple of years. And Earth has, for example, it has a starter API that's just an automation API where you can take like Socket, GXP, and talk to Earth. So if you're generating KML or imagery or terrain in Socket, you can actually push it over into Earth and drive the camera in Earth from Socket. So anybody from BAE Systems here? No, Mike Money is in some of these, but no problem. And then you guys know, I think, about online and enterprise. You saw the plenary this morning where they talked about some of the great stuff there. You can host your 3D in the cloud. You do have to have, for scene layers, you have to be going through the portal information model. So you can't just go against server for, like you can with classic feature services for 3D. So you have to be going through either enterprise or online as the offering where you're accessing layers. You can't go through server. And then we have a lot of content. In fact, today we announced that we've updated the world elevation, the 3D elevation that is in all those scenes as part of the base map with this 24-meter posting Airbus data, and it cleans up some of the areas quite well. Anybody can access it who has access to basically who's agreed to the ArcGIS Online terms of service. And we see it in some apps that are free apps. The 3D world elevation is the second most accessed service in the Living Atlas next to the 2D imagery base map. So, and then it's high up there in terms of numbers of accesses. And then you guys know we have developer tools all over the place, and it is my mission to help promote 3D and push 3D throughout the developer tools. Oops. Okay, so in general, what's new from 2017 in 3D is tons. We have had some core information model changes to support 3D data, such as Esri has introduced a vertical coordinate system support capability across the platform. So if you cook some 3D data from satellite imagery, and then you go out and you survey some 3D data, well, you're in one model, and this guy knows this stuff a lot better than me because he's a civil engineer. In one model, you're in a gravimetric vertical coordinate system, where up is not necessarily directly away from the center of the Earth, and in the other model, you're in this ellipsoidal vertical coordinate system, where up is directly away from the center of the Earth. And unfortunately, we have the problem set as Esri, where we have to help you bring together data sources from different places and make sure that they line up properly. And to do that, we actually had about a 2-year effort to create the first vertical coordinate system mechanism across a GIS platform in the world that I know of. So there isn't one in open source. There isn't one in any of the other proprietary vendor competitors out there that is like available for web, desktop, and mobile app consumption. So it's a really odd thing. It's very geeky, but it's an important thing for 3D. We've introduced interactive analysis and editing tools, which are available now in the 3D runtime. We have smart mapping in the scene viewer, and we have increased usability and platform integration with City Engine, and then, as it says, 3D in the runtime 100. Oops. All right. So I'm just going to talk very quickly about some of the areas that I have 3 guys on my team that work on specific areas in ArcGIS, and I'm just going to talk briefly about a couple of these areas. So there has been a tremendous amount of activity around the CAD and building information modeling market. So this is largely, it appears in 2 different places. One is the owner-operators, like a city. You'll sometimes find now that cities, their land records used to be about parcels, and then maybe it was about building footprints. Well, now land records departments around the world are starting to require submission of building information models in some cases as part of either the permitting process or approvals in other parts of the workflow. So cities and governments are starting to talk about building information models or modeling, and then the architecture, engineering, construction market uses a process called BIM to drive efficiency in the construction and design process. The stat is that the world needs to spend about $3.3 trillion a year on infrastructure design or infrastructure renewal and creation. We only are able to spend about $2.6 trillion, and to get to that $3.3 effective trillion in spend, we need to drive more efficiency out of how we spend dollars on construction projects. So it's a big area in terms of like capital equipment and stuff like that. It's a huge area for software too. I think it could easily be Esri's top market in the future. The whole story for us in the last year or so has been combining GIS and BIM in some pattern that makes sense. They're never going to be smoothly interoperable, perfectly interoperable, but they are distinctly different workflows and data types and processes. And we can do better to make them work together. As the slide says, GIS informs BIM. So you guys, yeah, you're getting the right thing. GIS is used to inform BIM, so civil engineers need GIS data to start up their projects. Increasingly, they're being required to use GIS data to start up projects. And then BIM also is used in the lifecycle management of assets. So cities are requiring digital submissions because they want to use the data at some point in managing the environment and the city system itself. We are not trying to become a BIM company or reinvent what BIM is. So one fantastic thing is getting folks in Esri to realize that BIM is a distinct thing that we are not specialists in, right? It's not just disorganized CAD that could be organized by GIS. So we are trying to participate in the BIM process. In fact, anybody from the UK in here? So, okay. So in the UK now, there is this PAS 1192 standard that requires all construction projects larger than 200 million pounds to actually be conducted in a BIM process. And it even specifies that as part of the BIM delivery, GIS is a required component. So the moment that that standard clicked into practice, Esri UK started having these executives from AEC companies who had a GIS function but didn't know it, knock on their doors and say, can you tell us what this GIS thing is? So it's actually been driving a lot of interest in GIS from the AEC market in some of our areas. All right. We have this 3D platform that handles all kinds of different data layers and data types. And the BIM world is very interested in this. There is this nirvana of having a program management system that allows you to take a look at all of your BIM projects all over the world in geospatial context. And that is really one of the visions that we're trying to deliver working with Autodesk. And so taking all of these other data layers in a platform that's called ArcGIS and bringing in BIM information in some intelligent way so that you can deliver these interesting new experiences that should be possible in that market. That's one of the reasons why Autodesk is working with us. So we are doing things like hosting 3D object scene layers that can be used as context for large projects. We are, oops, come on, down. All right. We've helped introduce new formats for handling large reality capture meshes of areas, and which is being done extensively in the AEC market. So you go out, fly some drones, capture a large area, and then you cut out pieces that you don't want so that you can work on them with you can insert your BIM information. We're working on workflows to support things like that. Sean's going to demo point clouds in a sec. This is kind of a legacy data type that's been out there for eons, and we know that there's tons of it sitting around on dusty hard drives, and now we can take point clouds and help developers, help our customers stream them into interactive experiences that are very dynamic. All right, so I'm going to move forward a little bit. Okay, so another area that the team that I work with works on is urban planning and procedural modeling, and so a lot of this was originally related with City Engine. The City Engine itself has gone through some tremendous changes. We have embedded the procedural engine from City Engine inside Pro. A lot of the rules that work in City Engine will also work in Pro. So that's another place where we find people using development tools as CGA. The language for creating procedural rules is actually a pretty intense language, recursive language that it takes quite a bit of thinking to wrap your head around. But those rules are usable in Pro as well as in City Engine. City Engine is used to create 3D cities. It's used in some movies. There's a lot of hype about that. It's interesting. It's part of the movie production workflow. The area that we're focusing on, though, is using procedural to allow you to create concepts for future urban plans, things that don't exist yet. And then City Engine is being integrated tighter and tighter with the platform, so that the data being created and authored in City Engine can make its way up to out to other experiences. In fact, some of those experiences are things like the 360 VR app came out of the City Engine team, and we have lots of plans to expand that app and to do more around the transportable mobile workflows and more CGA stuff and all kinds of great stuff for City Engine. One of the areas that has been pretty interesting to see is we get a lot of demand, back to the beautiful maps comment earlier, we get a lot of demand for pretty 3D scenes. And at Esri, we have a little ways to go to get to like the true 3D materials, and these are things that Sean and I, both coming more recently from outside the company, have kind of like held up the red flag and said, we need to make prettier stuff. Well, sometimes the core capability to do that does not exist in Esri. And so we're working on promoting those core capabilities, and the development teams have been paying attention. But one of the ways that they've paid attention is to also figure out shortcuts to things like Unreal Engine. So now I think we were the first adopter of Unreal's Datasmith extension that basically allows you to pipe a certain type of FBX data, which is a common 3D graphics industry model format, from City Engine into Unreal. And once in Unreal, you can add rain and haze effects, and you can use it in a game, but what we find is there are a lot of people in the urban planning, engineering industry, and others that are using game engines for serious games. Back to the UK comment, we're finding that some government customers in the, the owner-operators in the UK are requiring VR experiences at the end of the construction process during commissioning so that they can actually train the operators on how to maintain the assets that are being delivered. So this is like a massive tunnel project where you need to know where all the switches are, or where you're gonna open the vaults and things to go and work on wiring. And they are actually being required to deliver VR experiences. All right, so what else? So let's see, let me just show a couple more things and then we'll move over to Sean. We're working a lot on exploratory and analytic tools. These are interactive tools while you are actually working with the 3D scene. And this is another thing that was a bit of a paradigm shift for Esri, right? A lot of the classic developers who worked on geoprocessing tools, just, in their heads, the output of a GP tool is something that gives you numbers and that you have a high degree of confidence in. But some of these tools, there are no numbers that come out of them. It's just a visual thing. Well, they're still highly useful, and they're extensively used in the military, in urban planning, and in other related domains. And we are now delivering some of these tools. The slicing tool in the upper left is something that's coming out in the next version of Pro. Javier demoed this the other day on stage. I think it was demoed today as well. This is a 3D area tool in the web scene viewer, and these things should be exposed for you guys as well. We've got some start into VR. All I'll say is that this is still a labs project because we have not yet, we just haven't yet decided to make it an offering itself. But you have access to it if you have City Engine. And let's see. All right, ArcGIS Earth. I've already mentioned it a little bit. I'm not going to talk much about Earth except to say, so Earth, it's a lightweight experience designed for knowledge workers, non-GIS people who need to aggregate and rapidly display data on a globe. It was originally designed to target the IC and DoD communities that were losing Google Earth. Google Earth is still going to be there for a few years longer, but we've had tremendous uptake of this in that community. And then we also see it used in education, and it's been amusing to see it presented back to me in a couple different customer environments. Okay, so actually we're going to switch over to Sean, and then I'll come back on with a little bit more road ahead. Three, if I can see it.
Come up. All right. So Chris kind of has given you an overview. How many of you have actually gone and dived in and actually published or created scene layers or tried to publish anything in the scene layer environment? Okay, so about 20%. So just to give you an idea, the amount of data that's available, as Chris said, out there is massive now. The whole of many countries in Europe, the Netherlands, Finland, Denmark, have national LiDAR data sets. Same for building data sets, and also for other 3D feature types as well. Like the country of Czechoslovakia has got an integrated mesh for the whole of the country. So it's a reality mesh for the whole of the country. So what I'm going to be talking about and demonstrating today is just an example of some of that data that's available. And what I've brought up here is the actual the parameters for the type of data that's available from the City of New York. So they have made available the whole of the City of New York's 3D buildings. So there's over 1 million buildings. There's LiDAR data available from the USGS, which was flown in 2014 right after Sandy. And there's also survey data available with over 600,000 trees for that area as well. So why is this useful? So I published this about 1.5 years ago, and since then, the scene that I published has been hit over 11 million times, with a hit rate of about 32,000 per day. So that's, that's just one web scene out there of many. So when you create something in 3D, it has a lot of value. I'll be showing the types of value that you can get out of it at the end. But this is just, these are just, it is a measurable thing, what you can actually get out of this type of information. And then, so the cost and things like that, these are just some of the size of data. So the Netherlands, they have 638 billion points in their data point cloud. That was captured back in 2007. They're now in the process of redoing that, and they're already up to 43 billion for some areas. The Norway Cadastre group, they have 3D buildings for the whole of Norway, and that's 18 million buildings at LOD 3. So LOD 3 is where you can actually see the balconies and fences around the houses, and it also has architectural details as well. So at the end, I'll be showing a couple of custom examples, and with that you can visit and check out as well. So these are some of those examples that are going to be available. So what I'm going to do now is I'm going to jump straight into Pro. So how do you publish these data sets? How do you get them? How do you go from if you have 2D floor plans, or if you have 3D blocks, or if you have all this LiDAR data that's sitting in as Chris says, is sitting in a hard drive stuffed in somebody's drawer, how do you get that and make it more valuable and usable than it is sitting in the drawer? And get people excited about using 3D and actually have uses for it. So one of the ways of capturing and getting data is through drone flights. So how many people here have flown a drone or have gotten data from drones? So a lot more. So how many of you use drone to map? Not too many. Oh, many. So from drone to map, you can get the regular orthometric data, the DSM, but you can also it also outputs these actual 3D meshes as well. So this is just one quick and simple site way of getting a 3D data out and usable in your scene, in your workflows. Not only, so this is in Pro, but you can also publish this to ArcGIS Online or to an enterprise environment as well. So that's just that. So looking at so why would you want to take these data sets and turn them into scene layers, the I3S format that Chris was talking about? So this is New York, and I have the buildings in a file geodatabase. I have the USGS Sandy 2014 LiDAR data. I also have the... Oh, hang on a minute.
No, it's
what's happened? This is what's happened.
Yeah, you might need to duplicate.
Is that up? Okay, thank you. Okay, so this is... So everybody can see that now? Yeah. So this is the drone data I was talking about in Pro, and you can also view it in online and also in ArcGIS Earth as well. So this is the drone data. Then going to New York. So this is New York, and here we have the file geodatabase, the LiDAR data set, and also the points for the trees as well. So what normally happens when you load a file geodatabase, it will take a little bit of time. You have the spinning wheel down here on the bottom, and it will slowly draw each of the buildings in. So it's still drawing off in the distance. And then if you add your LiDAR data, it will add you anybody who's worked with LiDAR data sets, you know that it'll bring in the boxes first, and then it will slowly index into bringing in the actual point clouds themselves. So what we want to do with this is to be able to do that quickly. So if we bring in, these are the scene layers. So this is a set of scene layers which I brought in, and you can see it's runs very fast. And then if I bring in the point clouds come in even faster. And this is not, it's not a visual trick. This is actually the data that is in the file Geodatabase. You can query it. It has all of the attribution. The point clouds have all of the attribution that comes with them. So that's a usable set of data. And how you actually generate this is kind of what a lot of people are asking me. So if I go back here to our main scene, I've turned off the layers because I don't necessarily need them right now to actually do any publishing. So there are 4 different ways to publish. So to get this into a form where you can actually get it up online and make it usable, there are 4 different ways. So you are always going to be connected to either a enterprise on-premise portal or an ArcGIS Online organization portal. And to publish, you use, there's the ribbon version, which is to use the share tab, or you can publish for each of the individual features by using share as web layer. And those are 2 which work best for feature layers, so 3D objects, points, or imagery. So if you have an image layer, you can publish those as part of in that form as part of a web scene. For publishing point clouds, currently we have a GP tool because of the size of the point clouds. So the New York data is quite a large set of data, and what you need to do is you need to publish it as a scene layer package. And once that's been published, you can then upload and publish it to your ArcGIS Online or your enterprise account. So we have these 2 web scene forms to publish, or we have a tool in our Geoprocessing, which is create scene layer. And it's create scene layer package. So what it's doing is a scene is what you have in online. A scene layer package is a layer, so a feature, a point cloud, a mesh, or a point, which has been packaged up into a small folder and then can be shared either locally or to online as well. So we'll look at if we want to publish our LiDAR data. Each of these tools recognize the type of data that you're trying to process. So as you can see, it gave us the option of publishing either the building data or the LiDAR data. And we chose the LiDAR data. For the LiDAR data, we have intensity. All of the attributes that are in the LiDAR data set are publishable, and you can add or subtract those. The data will be published by default to a Web Mercator global coordinate system, because when you initially view the data, it will be viewed on the globe. So there is a transformation. So Chris talked about the vertical and horizontal transformations that we have and that we support. So these are here as well, and that you can actually apply them to your transformation. And then you just say what you want as an output and give it an output, and then hit the run button. And I'm not going to hit the run button here because there is over 400 individual LAS files, and it takes approximately an hour to process it and package it all up. But once it's all packaged up, I can then go, and that particular data set was, I think, about 34 gig. I can then go to the GP tools and use the share package. And this will allow me to navigate to my New York LiDAR data set. So we see it's 27 gig. And just open that. Give it a summary description of what it is. Add some tags because you want to be able to find it once you've uploaded it to your organization. Add some credits to where it came from. So that in this case, it came from the USGS. And then decide on who in your organization you wish to share it with. So once you've done that, you can then create a web scene, and then that web scene you can work with. You can either just leave it and publish it online, or if you wish, you can actually do changes to it on the desktop. So I'll just show you what I'm talking about now. So this is the New York. So this is the data that I showed you. I've packaged it up. I've published it to ArcGIS Online. I've gone to ArcGIS Online. I've done some notation. I've given some credits, given a description. You can add this to a story map as well. I've added some slides here. So we have the Statue of Liberty. And then I've using the attribution in the feature, I've also colored the buildings in downtown New York by their height. And along with that, I have had the tree survey I talked about earlier. I've also added that. And then in ArcGIS Online, you have the ability to symbolize those tree points based on the attribution in the feature. And in this case, I'm using the tree type and the actual height of the building itself to generate the 3D model for that particular building, or for that particular tree. So this is, this now is set up and organized online. If I wanted to make some edits to it or change it, or somebody in your department wanted to actually use it or take that and use it for their own, make their own changes to it, they can do that by going to Catalog, and then all they need to do is, this is why it's very important to add tags to your data so that they can find it. So I've added my New York 3D LiDAR. So I can just right-click on this, and it says Add and Open. So what it does is it opens a new tab with all of the actual bookmarks that I had before, and all of the symbolization and everything that's in there as well. So, and I can make necessary changes I need to do to this. I can go in here and I can say, okay, well, I would like to change the symbolization for the LiDAR. I want to go from elevation to classification. So I want to see what the different LiDAR points are, what are the classifications. So we have ground, water, rail, bridge deck, and high noise in this particular data set. And then I can also do things like modulate using intensity. So intensity is the amount of reflectivity that each point has, and it can add to making the point clouds much more readable in a human interface way. And I can then also look at the points and say, okay, well, I'd like to make them a little bit smaller, so they don't look like beach balls. And then once I've worked through all of this and decided, I like exactly what I've done, I can, maybe add some more bookmarks here. And and make any other changes I need to make. I can go back to the Share tab and click on the web scene again. And this time, because I am not trying to publish everything back up, it actually reads all of the data that's in the web scene and in the features. And you can make any changes you need to make here on that description. And then just you get an Analyze tab, and then you get a Share tab. And then the Share allows you to then publish that data up to online again. So while that's chugging away, have a look at, so that's a really large data set. So we have the ability to do smaller data sets, so city-sized data sets or regional area-sized data sets as well. So these are, this is just Portland, an area of Portland by the hospital and the river. And some of the data that you have that's come in is, we have our buildings. So this is the scene layer buildings. And the difference you will have between the actual buildings in a file geodatabase, or you can see up here we have appearance, the labeling, and then the data. So because it's a live set of data on your hard drive or on your network, you actually have all of these ability to do spatial joins and all of the typical GP tool processing on them. Whereas with the scene layer, it is exactly the same set of data, same geometry, same buildings with the same set of information in them. But because it's a cached format, it has it doesn't have the same connectivity to other databases or attribute information. And you can do things with this data that you can't do with your file geodatabase, your live data. You have the ability to actually, if you wanted to look at what a change would be or add something, you can actually hide the building that you want to change out and look at a new building. Okay. So, and then from there, work with those changes. So that's just a subset of the types of things that you can do in ArcGIS Pro in the publishing side. So just to give you some of the examples that we have online. So we have a 3D scene layers group in ArcGIS Online. So it covers most all of the different types of data that is available and the different types of applications are possible with them. Here's the New York data set again. We have integration between not only the point clouds and 3D buildings, but also integrated mesh. And then on top of that, Chris was talking about BIM data. So this is an example of a BIM data set for the University of Kentucky. And that has not only the exterior, but also the interior, all of the features, chairs, tables, and everything like that inside. And it has attribution for all of those as well. So depending on what your requirements are for facilities or uses, those are the types of things you have available there. Apps and development, there are a whole array of opportunities for using the different JavaScript APIs on the web and other tools in the Runtime and Pro SDK system. And just some of the examples of what has been done with the Manhattan data. So as I said, it's been hit over 11 million times in 1 year. So these are the types of things that people have worked with on them. So this is a skyscraper explorer. So along the bottom, it gives you the buildings are colored based on their year of construction. We have a slider here which allows you to see the buildings based on their heights. Each of the buildings then has got information and is connected to Wikipedia and Flickr, so you can see different images and also information. So that's all done on the fly. Here's a simple art gallery application, so showing where all the different art galleries, and it's been artistically rendered to give a different feel for that data. So it's the same underlying data providing the basis for these types of renderings. We have this net zero or vision zero, so in looking at traffic accidents and number of cyclists and pedestrians that have been hit in real time. And then also looking at crime trends. So these are all the possible examples of development that you can run against 3D, and why it is, as Chris said, is making it makes a very strong story for people to tell different things as against a flat map as well. So in the online environment, we have a whole set of we have a JavaScript API with a whole set of examples, which allows you to code against the different capabilities of the 3D environment that we have. And there's you have a sandbox to change things around and look at the different capabilities that you can add to any of the 3D data sets that we have. So I hand back to Chris and he can finish up.
All right, thanks, Sean. So just to be clear, are there JavaScript programmers in here? Yeah, okay. So everybody, hopefully you guys know that you can go up and explore in the sandbox, right? Even a former developer, reformed developer, PM like me can go up. And a couple weeks ago, I just wanted to play around a little bit, and I put together this ISS tracker, and there's a project I was thinking about working on with my son, and he was pretty fascinated. This is where the ISS has moved since Sean started talking approximately. It's just a few lines of code that I was able to just go up there without even signing in and experiment with a little bit of Esri 3D in the browser. So anybody can actually go up and play with developing a simple web app in our sandbox without requiring login. If you can discover the public endpoint for the New York City buildings that Sean demoed, you could actually bring those into this environment without signing in and without having a license, and just play around if you want. So it's really accessible for anybody to go and explore with. Same thing with our developer SDKs for Runtime, right? You can use those for free, experiment. You'll have the developer use only thing across the viewport, but you guys can go and access it without needing to go and have an ArcGIS license, even though I know most of you guys do already. All right, so 3D road ahead. So just a couple quick slides on what we're doing around 3D this year that might be of interest to you. So Scene Layers started out, like many things do with Esri, and even when I was at Autodesk, is kind of you visualize stuff first, then you enable doing things with them. So this year we're going to be working on making Scene Layers updatable. We're going to be modifying them so that you can kind of composite together different spatially indexed trees so that we can handle things like that BIM data better, so that it doesn't pop in and out the way that it did when Sean showed it. We are going to be working on this mobile scene package workflow. That should show up at the UC, and then we should be modifying or improving it after that. And then we're looking at a variety of different data types to start to include in Scene Layers, including this kind of regular gridded multi-dimensional data that we get brought to us, kind of scientific data and other things like that. The Web 3D experience has seen some tremendous changes in the last year, because once the team established the core of it, they were able to start to gold and platinum plate it. And that's a good thing for all of us. So we are going to be introducing a masking and replace workflow soon. We're going to be improving navigation so that you can have like a walkable style navigation mode, and then you can even go underground in the global scenes. They're going to be working on simple sketching tools that definitely should be part of the API. In fact, a lot of these things show up in the API before they show up in the scene viewer or in one of the other WebGL experiences. Sean talked about and showed a little bit of the interesting edge rendering stylization that they're working on. And then Web App Builder is also going to be moving to the 4X API. The really good thing about that is so far, Web App Builder the last couple of years has been split 3X API for 2D and 4X API for 3D. That has kind of impeded development of widgets that can work across both of those. And so I'm hoping that we'll start to see more widget development once we can move to the 4X API for both of them. BIM GIS is going to be a huge part of the story. Like I said earlier, I fully expect that BIM, the whole AEC market, could become Esri's largest market in the next few years. It's a massive market. The world is changing. What we have to do as kind of the geodesigners in the room need to help influence and guide that change in healthy patterns. And I just can see already there's tremendous interest in BIM. The other day we did a hands up on the partner conference audience, and I asked if people were interested in BIM, and pretty much everybody in the audience held up their hands. So there's tremendous interest in it, and we will be doing things ongoing with Autodesk and probably some things with Bentley and probably some things with others in the market as well going forward. Interactive tools, the things we've started out with, Viewshed, Line of Sight, ViewDome, and then pretty soon the slicing tools, 3D Measure. Those are like the first 5-ish things out of 18 to 24 or so things that are in a list that we have that we need to work on. And so we'll have a lot more interactive tools that allow you to manipulate assets in scene. This also is going to expose other capability for you guys to build tools to actually slice up and manipulate 3D assets in scenes. Mobile 3D apps. Like I said, I have a prototype mobile app for 3D on my phone for the first time in 3 or so years here. That app is up on GitHub now, and you can go grab it, just bit.ly 2018 mobile 3D Android, and you can download the code and experiment with it yourself. Earth Mobile is planned for later this year, at least in beta, and then we are also looking at some kind of iOS-based 3D Explorer app. And then we have urban planning tools are going to be expanding. We have some new efforts at Esri to kind of package solutions or experiences for complete experiences, and urban planning is one of the areas where we're working on new stuff to support that market. We have time for a couple questions if anybody has them, but I hope this has been helpful for you. There's a lot of content, I know. All right, any questions from you guys? Yes, sir. Why not export a VR scene from Pro? We definitely need to. I mean, there's no question but that we should be enabling that, right? This is some of the effort of trying to turn a historical aircraft carrier that was very focused on 2D maps. The same people who back in the day had to decide whether they should make maps color are now having to decide which maps should become 3D. And for somebody like me, that question is nonsensical, because every map should be 3D, could be 3D, right? It doesn't have to be, but any map could be. And is a virtual reality or AR experience conceivable as a 3D map? Hell yeah. So Pro should definitely be able to export VR scenes. It's something that is first comes down to mind share. So sometimes what you'll find at Esri, and I saw this at Autodesk as well, is that one team will kind of prove that people want it, and then the other teams will move to it. And I'd say that was true for 3D in general at Autodesk as well years ago. The City Engine team is kind of right now proving out that people do want engine integration, VR experiences like this. And I fully expect that, like I said earlier, Pro is kind of the big digital content creation tool, authoring tool for 3D and 2D GIS. So it should be the authoring tool for VR experiences. So it's just something that will have to be budgeted for and put in the pipeline. Right now, it's the City Engine team that's focused on making that happen. So, but great question, and I asked the same question. So, in general, Pro should be able to export FBX and OBJ better and all those kinds of things. Because you create the 3D content in Pro and you should be able to get it out for other experiences. So, for those of you who know WebGL a little bit, we're looking at GLTF as a format that is more interoperable with the kind of modern WebGL market as well. We're definitely looking at these things. Other questions? How many of you are using VR or AR? Okay, any wearable stuff starting to go on out there that may not even have a visual mapping component a little bit? All right. At the UC last year, we actually had people who were already using wearable tech with 3D data behind it in the audience in production. So that was a surprise to many of us. So that market is definitely moving forward fast. And GIS data, whether used for visuals or not, feeds some of those experiences. Other questions? None? Yes, sir. Interactive tools. Interactive tools. So the scene viewer already has some 3D measurement tools, but they're looking at slicing and so cross-section tools, view shed, line of sight, that kind of stuff later this year. It's customers right now. So they're extremely web first, and mobile too. We're seeing some whole customer agencies ditch desktops and basically just hand out mobile apps, mobile phones and tablets. They're in place. Yeah, I know, but we're getting the demand for it, so we have to figure it out, and we have been. So, yes, sir.
Would it be a walking mode coming up? Would that be able to be, or will it be integrated with, say, like a routing network?
So it could certainly be. I don't. So it could be. What I've seen is that sometimes the routing experiences don't need the walking mode because it's kind of two different types of experiences, but conceivably it could be. I don't think we have any plans to roll out a product capability around that yet, but we have this whole ArcGIS Indoors effort now, and they have definite plans around guided navigation around interiors, and I would certainly think that team will probably drive that requirement. So, yeah. Okay, good questions. Yes, sir. Is there any collaboration going on with Unity or Unreal? So absolutely. In fact, that's why we were an early adopter on the Datasmith Unreal mechanism, which was brand new last year for Unreal Engine. The GM of Unreal Engine, his name is Mark Petit, and he used to be an SVP at Autodesk in the Media and Entertainment Group, and I worked for him. And actually, fortunately, I had nothing to do with that Datasmith things, because other teams are actually making connections and starting to work with folks like that. So Unreal is, like I said, different teams experiment with different things. The City Engine team has chosen to focus on Unreal because it's kind of the more higher end Cadillac of game engine. And the Runtime team is working on a Unity kind of streaming capability, so almost an SDK for Unity, but it's something that they're experimenting with right now. I don't think it's ready for production yet, but absolutely. Last year at SIGGRAPH, Pascal Mueller from the City Engine, the director of that the Zurich office, was on stage with Mark Petit and a bunch of my former colleagues who used to be at our Autodesk and are now at Unreal. So it's incestuously small. The 3D graphics industry is even more incestuously small than the GIS industry, and it's there's definitely a lot of collaboration there.
Can we
Can you grab?
Grab one, two, three. Like we do with local government data, we have packages, and we grab.
So like drape them on? Drape. Okay, sorry. So no, you cannot right now drape imagery on a scene layer package, on a scene layer of any kind. The only thing I know that we do anything like that is you can project imagery into a point cloud and then RGB color the point cloud like that and then create a scene layer from it. Nope, we can't do that yet. And there's actually some discussion about that whole pattern because some people, like you can have meshes are truly 3D things, and what does it mean to drape an image on top of it? So there's some just philosophical discussions about what that even means right now. So right now, draping is on top of a DEM, and the DEM can be really high resolution, but there you can drape imagery on to your heart's content. But, all right, any other questions? All right, well, thank you all for sticking it out, and if you have any questions for us, please track either of us down during the show. All right, have a good show.